Welcome back. I thought I'd show you my office first, to show you the setup that I've got here. Thanks for the poster, John. And I've got the steering wheel here, which is the one that's it's called the Thrustmaster, and it's for PC games. And I've managed to link that into the LabView system. So I'm going to go back to the little robot that I had here, and what I've done to it is I've added a couple of things. So I've added a pan and tilt servo system and a tiny camera. I had the camera before, but the camera before wasn't this camera, it was an ordinary USB camera. So this camera is what's called an FPV camera that they use on model aircraft. So I think it stands for first person video, and it gives a PAL or an NTSC output. I've switched it to PAL for this country, and I've got a little transmitter that can transmit PAL, the TS832 transmitter, and it's got a whole lot of channels, of 40 channels. I've selected channel 12. I've got a receiver here, and I've put the output to a screen here. I've had to convert it to HDMI with a AV to HDMI converter. It does actually take sound as well, this transmitter, which is rather nice. But what I've done is I've taken some of the buttons on the steering wheel and made them control the servo. So these are the buttons here. So this would be up, down, left, right. So if we go to the screen where the picture is, you can see that go up, down, and to the left. You should see me, and back right again. It's slightly, the reason it's slightly jumpy, I'll explain in a minute. It's sort of designed that way, really, rather than to be 100% smooth. We go to the LabView program. In the main part of the program running on the PC, I've put these little subs, and all they are really are counters that operate on a button, which are the buttons on the steering wheel. And every time you press it, there's an increment of 10 that happens in these loops here. I picked 10 because if you just increment by 1, it means when you press them it takes rather a long time to get from one end to the other. So I wanted them to sort of move a little bit faster. So what is it, 18 degrees or something every time you increment it, something like that, I don't really know. And so therefore it's much quicker to move. It makes it slightly jumpy, of course, but once you've got it set, you don't really have to be moving it all the time. So I've got two of these, one for pan and one for tilt. And you'll see them there, the red ones, that's the pan and the tilt. And that sends, that goes into these network shared variables. And so there's pan variable, tilt variable, and I send them through the network, the Wi-Fi, to the main program in the myRio. I've changed things slightly again here, in that I've set the myRio itself up as a Wi-Fi source with its own SSID. That way I don't really need to bother with having a wireless router. I can just log in directly into it from this Surface Pro that I've got here. I don't need the video that I had before, so this is blank. That's the one coming through the Wi-Fi. Although that still works, I'm not using it, so I don't really need it. I'm using wireless video, about 1,000 lines in the per picture sort of thing. Okay, so without further ado, I'm going to show you another demo, and this time it'll have a full screen on it, unlike before, so you'll have plenty to watch and there'll be no latency at all. So it's a big change. Now this is a little bit like I suppose a model aircraft drone, except for I'm steering it through the Wi-Fi, so it's slightly different than you'd normally come across. Thank you. Okay, back again. So put it down on the ground and I'll adjust the servo. There's up and down, left and right. It's not a pure left and right, as you can see. It slightly goes up slightly, and accelerator pedals here down on the floor, and off I go. And this actually takes sound as well, but I haven't got a microphone on it, so it's far easier to steer like this, of course, even though it's not normal steering, it's tank steering. You see how much easier this is. Now I'm in the corridor. You kind of don't know how quickly. That's almost at maximum speed. I'm zipping down. There's somebody in their office there. Now I've also put a light on the front so I can communicate there. The lamp is just a straight switch from solid state relay. Go into his office. Oh, somebody else there, and he doesn't even know I'm there. Let's turn around. Oops, that's the steering wheel come away from the table, that's all that is. So I can still continue. Let's go back to the office. Past a few others. Oh, that's because, let's go in reverse. That's not good. There we go. Turn round. Bit of a crash there. Past the photocopier again, and that's the big robot, of which of course we can apply the same, exactly the same steering algorithm. You see the odd blip in the, here we are, you see it down there on the, oh, can you see it? Turn the light off, turn the light on again, and move the servo. Should be able to see me. Right, so coming in, there I am, and back again. It's got pretty good steering and excellent picture. Reverse. There we go. There it is. So same sort of thing, except for I put servos in for the camera. It's a different type of camera. It's using the it's using analog this time rather than Wi-Fi, and the advantage of that in this case is that we don't get any latency at all, really. I'm not suggesting that's the answer, because it's got also, presumably, all sorts of disadvantages as well, but it's yet another approach. Thank you very much. Bye bye.